Okay, y'all, my final type of problem deals with formulas. And of course, these are a little bit more complicated because we've had all these formulas. But I think this is one of the ones towards the end of my PowerPoint, and I can't remember. I think I'm on problem number 4, so we'll call it that anyway. So this problem is the sine of 2 inverse cosine 3/5. And what you want to focus on here is this part right here, this inverse part. We're going to call that theta. So we're going to let theta be whatever that inverse part is. Now this is 3/5 is not on my unit circle. So what I'm going to do with that is I'm going to set up a right triangle. It's going to be in the first quadrant because this is a positive 3/5. And we know cosine is adjacent or x over hypotenuse. So my numbers go there. And if I do the Pythagorean theorem, I find that this number is a 4. And my theta is this angle that I'm looking at right here. Okay, so if I go back to my original problem, I find that I have to figure out the sine of 2 theta, because remember theta was this part right in there. That makes me think of the double angle formula, 2 sine theta cosine theta. And I finished that out by using the right triangle. So from my right triangle, I see that the sine is 4/5 because it's y over r, and I see my cosine is 3/5 because it's x over r. And if I multiply all of that together, I get my answer, which is 24/25. So that's not that bad if you can decode what exactly it is they want you to find. Okay, my next example, I think this will be my last example. I know you're glad about that. But this one is tan, and then it's 1/2 inverse sine a half. Okay, so again, I'll let this inverse part be my theta. So theta is the inverse sine of a half. And luckily, I know that. A half is on my unit circle, the sine of a half. So if I put that in my calculator or look on the unit circle, I get that that is 30 degrees. So if I go back to my main problem, that means I'm doing the tan of 1/2 times 30 degrees. I go ahead and do a half times 30, so that means I'm trying to figure out the tangent of 15 degrees. I want to do that exactly. I don't want to do that with the unit circle. So I can, and I can't because I don't want to do it with my calculator is what I meant to say. So what I want to do is use my sum and difference identity. So I'm going to rewrite 15 as 45 degrees minus 30 degrees. And then I'm going to do the sum and difference formula for tangent, which says that that should equal the tangent of 45 degrees minus the tangent of 30 degrees over 1 plus the tangent of 45 degrees times the tangent of 30. Now I could have, sorry for my bad handwriting there, I could have used the half angle formula, but I just like the sum and difference better. So that's why I'm doing that one. So now I go to my unit circle and I look those values up. So tan of 45 is 1. Tan of 30 is the square root of 3/3, I think. So I'm putting in all my values then. And I get 1 minus the square root of 3/3 over 1 plus the square root of 3/3. If I multiply everything through by 3 to try to get it to look nicer, my final answer is 3 minus the square root of 3 over 3 plus the square root of 3.